Hello everyone, myself Mrs. Archana Mhatre, lecturer in Electronics and Telecommunication Department. In this video, we are going to continue with the third unit of microcontroller and application, that is 8051 timers, interrupt, serial and parallel communication. Now here we will see the programming of based on the serial communication. Timer 1 as a baud rate generator. Timer 1 is used as a baud rate generator because it is simple to adjust various baud rates by using this timer. So whenever you will do the programming with the 8051 serial communication, then always we will use the timer 1. Initially timer 1 overflow interrupt should be disabled. Timer 1 should be set in auto reload mode. Depending on required baud rate, we can use the standard values from the table. That number should be loaded in TH1 register. Values to be loaded in TH1 to have 4800 and 9600 baud rate when crystal frequency is equal to 11.0592 MHz. Now if the baud rate is 4800, then TH1 value should be -6 in decimal and FAH in hexadecimal. Now if the baud rate is 9600, then TH value will be 03 in TH1 register in decimal value, and hexadecimal FDH value should be written. Now next we will see the steps for programming to transfer the character byte serially. T-mode register is loaded with the value 20H indicating use of timer 1 in mode 2, that is 8-bit auto reload mode, to set the baud rate. Now these are the steps to be followed. Step number 1 is TH1 is loaded with one of the value to set baud rate of serial data transfer. Step 2 is SCON register is loaded with the value 50H indicating serial mode 1, where 8-bit data is framed with start and stop bit. Step 3, TR1 is set to 1 to start timer 1. Next step is TI is cleared by CLR TI instruction. Next step is the character byte to be transferred serially is written into SBUF register. Then the TI flag is monitored with the use of instruction jump if bit is not set, TI bit into label, comma label, to see the character is transferred completely. And last step is to transfer the byte, next byte, then go to step number 5. Now next step for programming to receive the character byte serially. Step number 1, T-mode register is loaded with the value 20H indicating of use of timer 1 in mode 2, which is 8-bit auto reload mode, to set the baud rate. Next TH1 is loaded to set baud rate for serial data transfer. Then SCON register is loaded with the value 50H indicating serial mode 1, where 8-bit data is framed with start and stop bit. Then TR1 is set to 1 to start the timer. Then RI flag is cleared with the instruction CLR RI. Then RI flag is monitored with the use of instruction jump if RI bit is not set to the label to see the character has been received yet. Then next step is when RI is raised, then SBUF has the byte its contents are moved into the safe place. Then last step is to receive next character, go to the step number 5. Now next here it is the program to receive serial data bytes and put them in the port 1. Assume baud rate is 4800, 8-bit data and 1 stop bit. Now ORG is the start of the program, ORG 0000H. Then move Tmod, 20H, that means 20H value should be moved into Tmod register. It will indicate the timer 1 is selected with the mode 2. Then TH1 value should be -6 or -6 or 0 FAH, indicating that it has a 4800 baud rate. Then next, SCON register will be loaded with the 50H, that is 8-bit data, 1 stop bit, and REN bit is enabled. Then set timer 1 with the instruction set BTR1. Then wait for the character to come in, that means wait for the received flag. If it is not set, then jump on the same instruction, and if it is set, then jump to the next instruction. In next instruction, whatever value it is in the SPUF register, that can be transferred into the accumulator register, and then in next instruction, the accumulator value should be transferred to the port 1. Then clear the content of RI, that is clear RI flag, receive printer of flag, and for receiving the next byte, again jump to the here label, which is on this instruction. Then end of the program. Now next, it is a assembly language program to transmit the data 75H serially at the end of the transmission. Make accumulator content as FFH. Assume the baud rate of 9600 8-bit data and 1 stop bit. Again same, the T mode will be loaded with the 20H value, indicating that it has a timer 1 mode 2, and TH1 value should be loaded with -3, or it should be loaded with FDH, indicating that 9600 baud rate. Then SCON register value should be loaded with 50H. Start the timer, then move 75H data to the accumulator and call delay. In delay program, the accumulator content should be moved to the SPUF register, and check the status of the TI bit. Then it is set, transmit bit is set, then clear that bit, return to the main program where it can be left. In main program, last we have to make the accumulator content as FFH. So the value FFH should be moved to the accumulator. Now next, this is a program to transmit the message MSBT serially at baud rate of 4800, 8-bit data, 1 stop bit, and assume the crystal frequency as 11.0592 MHz. Here we have to send the character. We have to transmit the characters. So one by one character should be transmitted serially. Here you can see first M character is there, then S, B, T, E. So one by one character should be transmitted, and the character is always written in the double quotation mark. Now next, list the SFR used in the 8051 microcontroller. So these are the SFR list, which are a special function register list, which are used in the 8051 microcontroller. First SFR is accumulator or B register, then DPTR, then program counter, stack pointer, PSW, that is program status word, then port latches, that is port 0, 1, 2 and 3, then serial data buffer, SBUF, serial control, SCON register, timer register, that is timer control, timer mode, that is TCON, TMOD, TL01, TH01, then power control register. Then next is a interrupt enable, IE, and interrupt priority register, that is IP register. So these are the list of special function register which we are using in 8051 microcontroller. Thank you.